Question 6 says a 53.4 centimeter diameter disk rotates with a constant angular acceleration of 2.6 radians per second squared. It starts from rest at t equals 0, and a line drawn from the center of the disk to a point P, the rim of the disk, makes an angle of 57.3 degrees with the positive x-axis at this time. A. Find the angular speed of the wheel at 2 minutes and 2.30 seconds. B. Find the linear velocity and tangential acceleration of P at 2.3 seconds. And C. Find the position of P in degrees with respect to the positive x-axis at 2.3 seconds. And so here's what we have is a disk, and it has a radius of 53.4 centimeters. And if we call this our x-axis, it's starting out at exactly 50. So this would be 57 degrees where it starts out. And actually, this is the 53 is the diameter, so the radius would be half of the diameter. So radius is 26.7 centimeters, and so we got to convert that to meters. So the radius equals 0.267 meters. It tells us that the angular acceleration is 2.6 radians per second squared, and it tells us that it travels. Its initial angular velocity is 0, and it is rotating for a time of 2.3 seconds. And so we need to find the angular speed. I said angular velocity again here, so it's angular speed. So we need to find the angular speed final at 2.3 seconds. So we can set up the equation of the final angular speed squared equals the initial angular speed squared plus 2 times the angular acceleration times the angular displacement. Actually, I don't even know why I use that equation, because it leaves 2 variables that we don't know. And so let's use an equation that only uses 1 variable. So if we say the change in angular speed divided by time equals the average acceleration, then we can simply use this as the final minus the initial divided by time equals the average acceleration. And so then we multiply and we get the final angular speed equals the initial angular speed plus alpha t. So when you plug in, that's 0, and then you have 2.3 times 2.6, and that equals 5.98 radians per second. So that's part A. Then in part B, the linear velocity. So if we say that angular speed equals the linear velocity divided by the radius, then we can solve for the velocity and say that velocity equals the angular speed times the radius. And the angular speed we solved in part A was 5.98 radians per second. The radius we were given in the problem is 0.267 meters. So multiply that out, and the linear velocity is 1.5966 meters per second. And so the tangential acceleration, if we say that the linear velocity is at this point at 2 minutes and 30 seconds, then we can just do the change of velocity. So it started out at 0, so the final is 1.567 minus 0 divided by the change of time, so 2.3 seconds, and that should equal 0.6942 meters per second squared. And that's supposed to look like a 6. And now in part C it says find the position of P in degrees with respect to the positive x-axis at 2.3 seconds. And so we can start off with the initial the equation that we were working with in the first place. So we want to find we know what the angular velocity, the angular speed is now. So if we have the final angular speed squared minus the initial angular speed squared, it should equal the angular acceleration times 2 times angular displacement. And so what we're trying to solve here is for angular displacement. So we have to divide by 2a, and so you get 2, not a but alpha, the angular acceleration, and so that would cancel that out. And we know that the initial is 0, so we simply have 5.98 squared. So I'm going to write this down here: 5.98 squared over 2 times 2.6 radians per second squared. And so this final angular displacement is 15.823 radians, and we got to convert that to degrees. And so, okay, actually, so I'm looking at this, and I don't know why I wrote down 15.83. So the formula we had was 5.98 squared. 5.98 squared is 35. So we're at 35.7604, and that was divided by 2 times 2.6. So that's 5.2. So when you plug in 35.7604 divided by 5.2, you get it equals 6.877. So 6.877 radians. So I don't know why I put 15. 6.877 radians. And so what we want to do is set up a fraction so that so if we say that there are pi radians in 180 degrees, it should be equal to the number of radians that we have, 877. Let me try to get rid of this. So we're only looking at this divided by the number of radians that we have traveled. So this displacement. So this total displacement in the 2-minute time period. Not displacement, but degrees. So we'll just put x degrees. And so you can solve this by taking 6.877 and dividing it by pi over 180. So this is going to equal 394 degrees. 394 degrees. But if you look at the problem, it says that he started out at 57.3 degrees. So you've got to add that in there. You get a total angle of 451.32 degrees. And now we want to put that with respect to the x-axis. So basically what we have here is our circle. Here's our x-axis. Here's where he started at. He went around 360, 394 degrees. So if this is 394 degrees from here, then it is 451 degrees from here. So it's all the way around plus some. So we can subtract, we can take 451.32 and subtract 360 to get our angle with respect to the x-axis. And so the answer to that is 91.32 degrees.